Let's be real for a second. If your AI agent feels slow, it's probably because it's built on a flawed foundation. Most agents are built sequentially. Step 1 has to finish before Step 2 can even start. That's toy thinking, and it's absolutely killing your performance. But don't worry, there is a much, much faster way.
Okay, so check this out. This visual just says it all, right? On the left, you've got your typical sequential agent. It makes 3 tool calls, one after another, taking a full 7 seconds. It's just sitting there, waiting. But the parallel agent on the right, it runs them all at the same time and gets the job done in just 3 seconds. That's less than half the time, simply by not waiting around.
And that wasted time? Oh, it adds up fast. If you're running just 10,000 requests a day, that sequential approach is costing you 55 hours of compute time every single day. That's not useful work. It's a pure latency tax you're paying for a bad architecture.
So, how do we fix this mess? The answer lies in something called the parallelism principle. And it is absolutely crucial to understand that this is not the same thing as concurrency, a term that gets thrown around all the time. They are not interchangeable.
True parallelism means tasks are executing at the exact same moment in time. This isn't some clever trick with task switching. It requires genuine multi-threading or multi-processing to actually use the power of your hardware. And this right here is the foundation for building agents that are actually production grade.
Let's really break this down. Concurrency, over on the left, is about tasks taking turns. It's great for things like waiting for a network request to come back, what we call I/O-bound work. But it doesn't guarantee things are happening at the same time. Parallelism, on the other hand, is what we need for heavy-duty agent work. Tasks run truly simultaneously, and it scales with your hardware. Look, a lot of frameworks will sell you on concurrency, but for real performance, agentic AI needs true parallelism.
All right, so I know what you might be thinking. This all sounds great in theory, but what about the real world? Well, let's get into the hard data, because the benchmarks, they really don't lie.
So let's take a look at a case study involving research paper analysis. This was done using a popular agent framework called LangGraph, and it's a perfect example of a complex task that has a bunch of independent steps that are just begging to be run in parallel.
This brings us to the big question, right? In a real messy scenario like this, just how much faster are we actually talking about?
Yeah, you heard that right. 137 times faster. That's not a typo. By switching from a sequential workflow that took over a minute to a parallel one that finished in less than half a second, the speedup was just mind-blowing. This is the difference between an agent that feels instantaneous and one that feels completely broken.
And hey, this isn't some one-off fluke. In a totally different case study, this time on multi-agent brief generation, going parallel resulted in a 37% gain in throughput. That means you're processing way more work, way faster, with the exact same resources. It's just a massive win for efficiency.
Okay, I'm hoping by now you're sold on the why. So let's get into the how. It's time to open up the architect's playbook. The big idea here is a design called the fan-out pattern. In a framework like LangGraph, it's handled by something they call a superstep. Basically, an input comes in and fans out to a bunch of different tools that can all run at once. The graph is smart enough to see this and automatically executes them in parallel. But, and this is key, it then waits for all of them to finish before it brings the results back together. So the graph isn't just allowing parallelism, it's actively managing the whole process.
Now here's a super important practical detail. It's tempting to just throw everything into parallel, right? But it turns out there's a sweet spot of about 4 to 6 parallel tasks. If you go beyond that, you start getting bogged down by the overhead of just coordinating everything, and you might even hit API rate limits. Your agent can actually get slower. So remember, more is not always better.
And this leads us to what is maybe the biggest challenge of all. You see, the hard part isn't just making things run at the same time. The hard part is managing the state. When you have multiple agents all running at once, how do you stop them from stepping on each other's toes and creating a total mess of your data?
The solution is actually pretty clever. You stop letting agents mess with the same data at the same time. Instead, you give each parallel process its own clean, private copy of the state. We call this an immutable snapshot. They do their work on their own copy, and only when they're finished are their changes merged back together in a controlled, predictable way. If you've ever used Google Docs and seen multiple people typing at once without it descending into chaos, you've seen this in action. It's the exact same principle, powered by something called a CRDT. To really make sure this all sticks, let's walk through 4 super common mistakes. Think of this as your checklist of what not to do, the traps that will keep your agent stuck in that slow, sequential world.
First up, and this is a big one, is the myth that async is parallel. It's not. In Python, async yo is amazing for waiting on things like API calls. But because of something called the global interpreter lock, only one thread can be doing real, heavy CPU work at a time. So even with async, your compute-heavy tasks are still effectively waiting in line.
Second, letting the LLM control the entire execution flow. If your agent is basically just a chatbot where the LLM decides what to do next, well, you've just hard-coded a sequential process by design. It's also unpredictable. For real parallelism, the structure you define, the graph, has to be in charge of what can run in parallel, not the LLM.
Third is the trap of unlimited concurrency. Remember that sweet spot we talked about? It's real. Pushing way beyond 4 to 6 parallel tasks usually just makes things slower because of all the coordination overhead. You have to be strategic about it. And finally, the cardinal sin, shared mutable state. I just can't say this enough. If you let different parallel processes all write to the same shared data at the same time, you're asking for a world of pain. We're talking about race conditions and bugs that are a complete nightmare to track down. Always use those immutable snapshots and a controlled merge process.
So that brings us to the final question, and it's one I want you to really think about for your own projects. After seeing the speed, the architecture, and the pitfalls, take a hard look at what you're building. Is your AI agent a clever prototype, or is it truly built for production? Because as we've seen, the difference is parallelism.